2.6 notes is over 2 days. This is the day one, and we're talking about modeling with functions. For the first problem, it says that a woman 5 feet tall is standing near a street lamp that is 12 feet tall, as shown on the figure. Now, it seems like this distance is 5 feet, and it's giving me a right angle here. Find the function that models the length L of her shadow, and here's L, in terms of the distance D from the base, and D is here. Alright, the first thing I would do is I would stick myself in the small triangle. In the small triangle, I'm talking about this triangle. I was only in this triangle if I'm trying to look for, let's say, the angle here. Let's say I pay attention to this angle, and I'll call it theta for now. If I try to find the tangent of theta, I would say tangent of angle theta is equal to opposite, which is 5, over the adjacent, which is L. Well, now I'll look at the big triangle. The opposite now is 12 over the adjacent, which will be L plus D. Now, using the two expressions on the right side, I will cross multiply to get 5 times L plus D is equal to 12 times L. After distributing the 5, I will subtract the 5L to get 5D is equal to 7L. Since I'm solving for L, I will say L is therefore equal to 5D over 7. Let's look at the second problem. The second problem says a gardener has 140 feet of fencing to fence a rectangular vegetable garden. What is the maximum area she can fence? It says define your variable. I would say let L equal the length and W is the width. Alright, I have my length and my width. So if I have a triangle like this, I will call the length L and the width W. Here we're trying to write what we're trying to maximize. I'll say L times W is the area. The next question says write another equation using the other given information and solve that equation for one variable. Well, the other given information is the perimeter, that is 140 in this case. Well, the perimeter is equal to 2 times the length plus the width. If I solve this one, I will say 70 is equal to the length plus the width. So I can end up with length is equal to 70 minus the width, or I can also say the width is equal to 70 minus the length. But with this information, I can rewrite my area as area is equal to length times the width. That's one way of writing it. But these two equations are good enough. The next question says write the equation of the quantity you are trying to maximize. Well, I was just ahead. This goes down here. The area is equal to, if I want to make it a single variable, or if I want to call the width X, I can go ahead and say the area is equal to X times 70 minus X, where X is, in this case I can call it the width. I could have said X is the length. It's all up to me. So width or length, it doesn't matter. Now here it says find the maximum area of the garden. Always check to make sure your answer is in the domain of the problem. So to find this area, on the y1 I will have X 70 minus X, and I will go ahead and solve for max. Once you use your calculator, you will get the max is 35 feet by 35 feet. So in fact, that rectangle was actually a square. All right, let's move on to number 3. Number 3 says a hockey team plays in an arena with a seating capacity of 1,000 spectators. With the ticket price set at $14, the average attendance at recent games has been 9,500. A market survey indicates that for each dollar the price is lower. The average attendance will increase by 1,000. Find the ticket price that will maximize revenue from ticket sales. Let X be the dollar amount. Now, the dollar amount that will be lower. Let's start with this. So to find the revenue is equal to the price times the attendance. So I will say ticket price times attendance. So to find the ticket price depends on how much is lower. So I will start by saying it is the original price minus the price that is being lowered. In the attendance here, we have 9,500 for sure, plus 1,000 times that price again. So if you want to solve this one, using your calculator again, you will end up with X is equal to 2.25. Guess what? This 2.25 does not quite represent how much the ticket price is. So to find the exact price, I will say 14 minus 2.25. And if you subtract 14 from 2.25, you end up with a dollar amount of 11.75. With this 11.75, the revenue will end up being 138,062.50. Use your calculator to get this answer. All right, let's look at the last problem. The last problem says a manufacturer makes a metal that can hold 1 liter of oil. Would radius minimize the amount of metal used to make the can? What is the minimum surface area? And it says label your unit. 1 liter is 1,000 centimeters square. The first thing I will do is, I know that pi r squared h, you should know this one, is equal to 1 apparently, because that's it, 1 liter, that's my volume. 1 liter of oil here, and I say V is equal to pi r squared h. The next thing I will do is, I will go ahead and solve for h. And to solve for h, I will say h, by the way, this is 1 liter, so before that I can say that means it's 1,000, this time in centimeters square. By the way, this is my volume. So I will say 1,000 is equal to pi r squared h. To solve for h, divide both sides by pi r squared. And I have the value of h here. Now, means that if I'm looking for the surface area here is 2 pi r squared plus 2 pi r h. I'll go ahead and replace h by its value, and this will give me 2 pi r squared plus 2 pi times the radius times 1,000 over pi r squared. From here, you just need to put this on your calculator, and if you put this on your calculator, you will find the minimum is 5.419 centimeter, and that will be your radius. And the maximum will be, not the maximum, but the surface area would be 553.581 centimeters square, and that's your surface area.